couple more examples working with inverse trig functions. These are a little bit more difficult, I would say. We are going to evaluate a sort of a composition of trig function and its inverse, or an inverse, doesn't have to even be its own inverse, without using a calculator. So we don't even get the advantages of a calculator here. Well, on this one, probably the most important aspect is to understand that the output from an inverse trig function is an angle, right? So this inverse sine of -1/5 is some angle. I'm going to call it theta, okay? And so what we're really doing is we're looking for the secant of theta, right? We want to find the secant of theta, where theta is the inverse sine of -1/5. Well, all that means is that if theta equals the inverse sine of -1/5, then that means that the sine of theta is equal to -1/5. And we know one other thing about this, and that is that the theta value is in a particular quadrant. Remember, the inverse sine only gives outputs in the, I think this one through, in the fourth and first quadrants. If the input to the inverse sine is negative, then the output's going to have to be in the fourth quadrant, and it would be a negative angle, okay? So we know this is true, and theta is in the interval from -π/2 to 0. It's going to be in that fourth quadrant with the negative angle, all right? So we know that stuff just based upon the input, the inside of the secant. So now, how do I find the secant of that angle? I don't even know what that angle is. There's no nice triangle either, no special triangle that will work with fifths, right? So it doesn't matter what the angle is. We don't actually need it. All I really need to do is to construct a triangle where theta is one of the angles and 1 and 5 are the sides. We'll deal with the negative later. I kind of already have dealt with it. So the 1 and the 5 are what's important, and we know that the sine being 1/5 means 1/5 is the opposite over adjacent, or opposite over hypotenuse, right? So for the sine, so that would be a 1 and a 5. So we can then find the third side using the Pythagorean theorem. It would be the square root of the hypotenuse squared minus this leg squared. The square root of 25 minus 1 is square root of 24. And that does simplify. 24 is 4 times 6. The 4 will become a 2 when you take the square root, so it'll be 2 times the square root of 6. Okay, so this other leg is 2 root 6. All right, so we're looking for the secant of that angle. Okay, so the secant of theta is the reciprocal of the cosine. The cosine is adjacent over hypotenuse, but we're looking for the reciprocal of that, so it's hypotenuse over adjacent. So this would be 5 over 2 root 6. Okay. However, I do have to factor in the fact that theta is in the fourth quadrant. Okay. If theta is in the fourth quadrant, both the cosine and the secant are negative, right? Just a refresher here. Oh, I'm sorry. Did I say negative? I meant positive. The cosine is positive in the fourth quadrant. I don't know what I was thinking there. Yeah. Just double checking my own mind here how this is going to play out. So the sine, inverse sine, that's going to be in the fourth quadrant. the secant of that is going to be in the fourth quadrant. Secant is positive in the fourth quadrant. So I think that should work. Yeah, 5 over 2 root 6. I was thinking that might turn out negative. Let me just double check that one. Because I stole that one out of the book anyway. Where is it? Oh yeah, it would be right. But I'm not done yet. What am I thinking? Why am I not done? We've got a root on the bottom. We can't have that. That's like an automatic point deduction right there. I can't do that. Yeah, so we got to rationalize that denominator. Let's multiply by root 6 on the top and the bottom to get rid of that root. You're going to end up with a 5 root 6 on top. And then 2 root 6 root 6. Well, the 2 is going to be there. The 2 root 6's make just a 6. And then 2 times 6 will be a 12 on the bottom. So this will be 5 root 6 all over 12. That is a good answer for this one. All right, so let's go ahead and move on to that next problem that I have over there. I'm going to have to erase some of this to give myself a bit of space. We'll start with that much, and we'll probably have to erase more as we go. This one's a little bit crazy. We've got the tangent of the difference of 2 inverse trig functions. Well, again, I always think about these inverse trig functions as angles, okay? So that's the first thing I really want to do. I'm going to go ahead and give them each names. Now these could be different angles. I don't even know what they are. In fact, just looking at the 2 ratios here, I'm going to assume they come from different triangles because I don't think the Pythagorean theorem is going to really follow through here. So I'm going to call that first one angle A, and the second one angle B. You can choose whatever variables you want. I like these though because they're going to match a formula in a minute. We have tangent of A minus B. You may know what I'm going to be getting at here in a moment. Okay, so let's color coordinate. Angle A. Well, angle A comes from the cosine, right? So that tells us that the cosine of A is the square root of 3 over 2. If I were to construct a triangle for that particular angle A, cosine is adjacent over hypotenuse. So that's root 3 and 2. The third side is important here. It's going to be found using the square root of the hypotenuse squared minus the other leg squared, which is 1, right? Square root of 1. So that one's not too bad. And then over here for angle B, I know that the sine, so we're dealing with the sine, so the sine of B is negative 3/5. Well, B again, I can make a triangle for angle B. Now I'm going to ignore the negative, we'll come back to that negative. B is going to be, let's see, sine is opposite over hypotenuse, so it's 3 and 5. And then this guy here is the square root of the hypotenuse squared minus that side squared. Well, that's 25 minus 9 is 16. The square root is 4. So that equals 4. It's a 3, 4, 5 triangle. That makes sense. Okay. All right, so now I also know that B has to be in the 4th quadrant because the inverse sine of a negative will be a negative angle in the 4th quadrant there. So B is in quadrant 4, and I also know that A, well, the cosine, inverse cosine of a positive value will be in the 1st quadrant. So A is a quadrant 1. angle, okay? If this ratio was negative, the cosine is negative in the second quadrant, the way that graph works out, okay? So we know the quadrants of those angles, which is important. So now, what are we really looking for? We're looking for the tangent of A minus B, right? So we're looking for the tangent of A minus B. Well, we have a formula for that. Comes from a prior section. It's the difference formula for tangent. And it is the tangent of A minus the tangent of B all over 1 plus, if I'm not mistaken, tan A tan B. So in order to evaluate this, I need to use my formula here with the tangent of A and B. So I just have to find the tangent of A and B off of these triangles and plug them in and simplify. Sounds simple enough, but it isn't. So the tangent of A, let's go back to angle A. Tangent of A is opposite over adjacent, so it's 1 over root 3, or if I rationalize that denominator, it's root 3 over 3. Okay, going over to B, if I want the tangent, I'll put it over here on the side. Tangent of B, again, it's opposite over adjacent, so it's 3/4. But remember, quadrant 1, or A is in quadrant 1, which makes this positive, that's fine, tangent's positive there. But B is in quadrant 4, tangent is negative in quadrant 4. So we want that to be a negative 3/4. Now I have to plug everything in. So my tangent of A is going to be root 3 over 3 minus the tangent of B, which is negative 3/4, all over 1 plus the product of those two values, those two tangents. So it's root 3 over 3 times negative 3/4. That looks pretty nasty. Let's see if we can get that to simplify it all. This numerator, I need a common denominator, right? The 3 and the 4, let's make them 12. So I'm going to need to multiply by 4 here and multiply by 3 on that one. The double negative will become a plus. So let's see, we're going to get 4 root 3 over 12 plus 9 over 12. And then my denominator has a 1. Oh, let's simplify this. The positive with the negative is going to be a negative. The 3's will cancel. So it's going to be root 3 over 4. Right? So this is 1 plus root 3 over 4. To get a common denominator, I want that to be 4 over 4. 4 over 4 plus root 3 over 4. So I'm going to make that 4 plus root 3 all over 4, make it one fraction. And then my numerator here I can make into one fraction as well. That's going to be 4 root 3 plus 9 all over 12, all over 4 plus root 3 all over 4. Now I do copy dot flip. Now that I've got the numerator and the denominator, each one is a single fraction. Now I'm definitely running out of room. So let's clear up a little space to the left here. Let's see. That's going to be 4 root 3 plus 9 all over 12 times 4 over 4 plus root 3. Again, copy dot flip on those fractions. Multiply by the reciprocal. The 4 and the 12 will cancel or reduce. And so we're just going to get 4 root 3 plus 9 all over, and I could distribute this 3 if I wanted to, be 12 plus 3 root 3. Well, that looks a bit messy, but, oh, it's not done yet. Again, I did not rationalize the denominator. I'm just going to check that. Yeah. That looks like it's going to have to rationalize. Okay, so I'm not done yet. Erase the circle. How do I rationalize the denominator when there's more than one term on the bottom? Conjugate, right? You multiply by a conjugate. So here I'm going to multiply by 12 minus 3 root 3. And here 12 minus 3 root 3 on top. Now I've got to distribute all that stuff. Oh my. Okay, so this is going to become a bit messy. 4 root 3 times 12 is 48 root 3. 4 root 3 times 3 root 3 is going to be 12 times 3. Oh, right? 4 times 3 and root 3 times root 3. That's 36. I'll come to that in a minute. Then 9 times 12 is 108. And 9 times this is negative 27 root 3. That's my numerator. Be able to simplify that pretty well. My denominator, pair of 12, that's 144. Because we're multiplying conjugates here, when you do the distributing or the FOIL, the O and the I will cancel out because they'll be opposite sign. So we're left with just the F and the L, which will be minus 9 times 3. Okay, so I'm skipping a couple steps or doing them in my head, but I spoke them out. Hopefully you followed that. And then got a little bit more to do. Here's a 48 root 3 minus 27 root 3. 48 minus 27 is 21. So that's 21 root 3. 12 times 3 is 36. If you do 108 minus 36, you're going to get 72. And then on the bottom, 144 minus, this will be a 27. 144 minus 27 is 100. What's that, 117? Is there anything we can factor out and cancel? Yes. There's a common 3. 21 and 72 are both divided by 3. 117 is also divided by 3. So if I factor out a 3 from this numerator, I get 7 root 3 plus 72 divided by 3 is 24. Need more space again, my goodness. So that's 24. And 117 is 3 times something. 39? No. What is that? 3 into 11 goes 3 times. The remainder 2, 27, yeah, 39. Yep, that's right. Okay. So then I can cancel my 3's. And I should be left with 7 root 3 plus 24 all over 39. Really hoping that one worked. I'm going to check it. Well, my denominator's right, but the rest is not. Let's see. That should be 27 and that should be 48. Really? So apparently I did something wrong along the way. Probably in all this mess up here. Did I copy something wrong? That times that is 48 of them. That times that is minus 12 times 3, 108. That looks okay. Difference of the squares. That's good. That subtraction was right. Make a sign mistake? Well, I love making mistakes in these videos. Now you can see that even I'm not perfect, and of course, I found it. So right here, I didn't factor my negative. How many of you guys saw that as I was going and you're like, he's doing it wrong, he's doing it wrong? Probably nobody? Maybe somebody did, I don't know. Anyway, I missed this negative. I remember catching it as I spoke it, but I didn't write it down. So those should have been minuses right there. That would make this a minus. I'm just going to retrace the footsteps from that point on. That would make that a minus, which makes this a minus, which then makes both of these pluses to be conjugates. And that changes a bunch of stuff on this row, but only the signs. So let's see, still positive, that's going to be positive, that's positive, that's going to be positive now. So just change two signs there. And on the bottom, it didn't change anything. I still get 144, the middle terms cancel, and that's negative. So that bottom actually ends up okay. So that's why the 39 was the same. That makes sense. So now my numerator, when I combine these, will be different indeed. I get 48 plus 27. What's 48 plus 27? 6875. So that's 75 root 3. And then 36 and 108 is 144. Again, you can pull out the 3. There is a common 3 here, but that's going to leave me with a 25 root 3. And pull 3 out of a 144 and you get what is that? It's 12 times 12. So it's 48. That should be 48. Yeah. 144 divided by 3 is 48. Okay. So then you cancel those out, and the final answer will change now to the correct answer, which is 25 root 3 plus 48 all over 39. That's the answer I see in the book. Yes. And we're good. Okay, so I apologize for that mistake, but with all that work there, all I needed was to miss a negative, right? And then the whole thing is messed up. But we got it to match. This is a good answer down here. And it is rationalized. There's no root on the bottom. I'm glad we went through all that work to check it. So, quite a neat problem right there.